Okay, I apologize for the technical difficulties. I'm definitely having some issues. Just before I started all this, my Mac took a crash. So now I am recovering. This will only happen if you're doing a keynote, so don't worry about that. So hopefully everybody can see what's going on, and I'll watch the messages, and if we don't, but I'm gonna go ahead and get started. I hope you can see my screen. I hope you can see me. My name is Eric Johnson. I'm a principal developer advocate for serverless. And one of the jobs as a principal developer advocate for serverless is when your machine crashes, you have to roll with it. And there it is. So again, I apologize for that. So let's jump in and get started. I'm so excited to be here at Serverless Days Nashville with y'all. I got to come last year and where we did it live, and it was so well done. I was so excited to be asked back to do this. So thank you for having me back. You probably will never have me back because I can't use Zoom, obviously, in virtual. This is another reason why Eric is always better live or not. We'll see. We'll see how that turns out. But all right, so let's go ahead and jump in and get started. Today, I'm going to be talking about the things I got wrong in serverless development. I've been doing service development for a long time, and there is a whole list of things I got wrong, but I'm not going to cover them all. Hopefully, I'm going to give you enough that you can, you kind of get an idea of, hey, I'm gonna bootstrap those. I'm going to get on by those and get to some of the good stuff. So, a little bit about me. Like I said, my name is Eric Johnson. I am a principal developer advocate at AWS Serverless. I've been a developer forever. I've been a solutions architect forever. And so I've been doing that for as long as I can remember. Why I do it? I do it to take care of my family, right? I love technology, but I love taking care of my family. I'm a husband of one. I'm a father of five. I am a drummer. I used to say musician, but a lot of people would fight back on that. Yeah, just a drummer. So, okay. And I'm a pizza lover, avid Diet Dr. Pepper drinker. I've already seen comments in there about getting Eric a Diet Dr. Pepper. Eric doesn't come unprepared. I got my Diet Dr. Pepper. We are good to go. All right. Now, what I'm going to do today is we're going to talk through the agenda here. And here's the agenda. It's pretty simple. I'm going to give you a quick history. I'm going to tell you the mistakes I made. You can laugh and roll your eyes at me, and then hopefully you learn from my mistakes. So that's the agenda for today. So let's do a quick history of quote serverless. Now, there's a couple of rules when I'm talking, just so you have them. If you've never heard me speak and you may be thinking to yourself, who are you to make rules? I'll just hang up if I want to. That's true. But there are more guidelines to help understand. First thing is, this is any number I want it to be. Okay, so I may hold up one finger and say 7. You got to listen to what I'm saying. I just always do that. Hey, table for 7. I end up sitting alone at the bar, so you get used to it. The second thing is these are quotes, not apostrophes. Excuse me. So if I do this, the other day I was working. Those are double quotes, which looks a lot better than this looks kind of silly. People think I'm doing the bunny rabbit or something. And finally, these are thumbs. I do this a lot. My actual college ID is. So those are the rules, those are the guidelines, those will help you. I do make one finger jokes. I'm comfortable with it. I have a lot of fun with it. I will tell you that if that makes you uncomfortable, I'm okay with that too. So I'm going to be comfortable either way. All right, let's jump in and get started. So in November 13th, 2014, AWS introduces a preview of AWS Lambda. Now, we're saying here serverless was announced, but really we didn't call it serverless at the time. It's kind of a word that came out and has been coined as this idea, but we call it AWS Lambda, which was an event-driven computing service for dynamic applications, right? And on April 9th, 2015, AWS Lambda became generally available for all to use. And I remember thinking when I saw this, I remember the day, and I was staring at the screen and they were showing this, and I thought to myself, why would I do it any other way? This is the coolest thing ever, right? Basically, if I think about this, something happens, and this is how I define serverless a lot. People go, oh, what do you call serverless? And it's like, okay, ready? It's very technical. Something happens, we notice, and we do something, right? It's this event-driven model without any compute that you have to manage and all that kind of stuff under it. But when we're talking about Lambda functions, That's kind of how it works. And to get a little more technical, we talk about event sources, changes in data state or request to endpoints, things like that. And then it invokes a Lambda function. You can use one of many different languages or the runtime API where you can use your custom language. And then we do something with it, right? We affect a service. We change data in a DynamoDB. We will do something third party. We can turn a light bulb off and on. We can flush a toilet through, that's kind of weird, but it can be done, right? So it's this idea of event-driven data and Lambda functions, that was the beginning of this idea. But then it kind of blew up from there. And rather than just having these Lambda functions, it came into, now we got compute, we got queues, we got gateways, event buses, orchestration, pub sub setups, databases, storage, and much more of managed services where you only pay for what you use. You don't have to patch. You don't have to upgrade. You don't have to manage physical security. It scales up and down as you need it. Most of them scaling to 0, and so on. And so with serverless, I looked at that again and I was like, why would we do anything different? Now, as I was preparing for this talk, I sent out a tweet and I said, I want to know when you were doing this, what did you have to do? What did you have to change in the way you think when you're doing serverless? If you want to follow that thread, it's kind of interesting. s12d.com/what changed. You can follow this QR code. But I wanted to read just a couple of these as we dig in and as people were kind of wrapping their heads around serverless. So the first one, a good buddy of mine, Matthew Bonnick, said, I had to be much more comfortable doing unit testing and not relying on E2E integration testing to make sure things work. All right, so some changing in testing. Abraham said, for me, it was understanding the decoupling and how to integrate with all services and how everything fits together. SQS or SNS, why I need it in the first place. Aaron Brighton said, maybe not change, but challenge. Getting trapped repeatedly in the analysis paralysis of trying to find the best way of doing something. And that's a challenge that I've had as well. It's like, okay, what's the best way? I know 10 different ways to do it, but what's the best way of doing that? I get that, Aaron, I agree. Alan, I love this. Says, a big surprise to me was debugging. I went from line by line debugging to console logs. I felt like it was a step backwards at the time, but I feel like I genuinely solve problems faster. Very interesting, all right? I love this statement, Matt Gillard, I may say it wrong. I say Matt right, I'm pretty sure Matt's right. Thinking ephemeral is a game changer, and it made it all click for me. This thinking this thinking helps with non-serverless as well. I remember this idea of ephemeral, and I actually wrote a blog when I was at a partner, Rackspace. I wrote a blog, said first we had our pets, then it was cattle, and then it was insects. This here for a moment and gone. And serverless is very ephemeral. That's a good way of thinking about that. And Sebastian said, writing event-driven code rather than chaining functions together took a little time to adjust to. Yeah, I can understand that. All right, so what we're going to do now is I'm going to jump at some of the mistakes I made, and I added one this morning, and this is mistake number 0.5, but I thought it would be fun to share with you. When I originally signed up to do this, I didn't know I was going to have to be in Seattle, so I was traveling while I was preparing for a keynote. And so mistake number 0.5 is to be out of town for a virtual keynote. So I thought it'd be fun to show you. I thought I would have all this fancy stuff, but here's my setup. Here's what I'm looking at right now. And you'll notice I've got my Dr. Pepper there. So, there we go. All right, let's jump in. Mistake number 1. Now remember, it's the thing I say, but in this case, it's the finger I'm holding up to. I'm pretty proud when I can do 1 and 2. I can get to 4, but I have to take my shoes off and it just gets awkward for everybody. All right, mistake number 1, rolling my own development environment. Now, if you started serverless on AWS, most of us started here. Now, this is probably a little updated from what you may have seen, but most of us started with that console, right? We went in and we built that first Lambda function. We may have wired up an API gateway or some other sort of trigger source, and we may have given it permissions to go somewhere else. But the problem with that, while you could do so much in the console, it's not scalable. right? So if I take and I built this all out and I get this perfectly working application and I say, okay, I want to give this, I want to launch it in a new region. I want to give it to my buddy and tell her to, hey, here, you can launch this. And she says to me, well, how do you launch it? Follow the script. Click here, push that, click that, click that. Oh, I may have got that wrong. Oh, it's not scalable, right? So then we kind of turn to writing our own scripts. Anybody remember this? I used this. I had scripts wrapped around this where I would zip up the Lambda function and I would call the Lambda function create button or the update function code. I remember Alex Debris and Alex, I hope you're out there or this gets back to you. You and I were sitting in a dinner, and at the time Alex was still working for Serverless Framework. And of course, I'm a SAM person. If you're not familiar with what these are, I'm going to talk about them in a little bit. But I do SAM, Alex does serverless, but we both have this agreement that we work with frameworks, right? And we were sitting across from a gentleman, and he was saying he was building this amazing serverless application. And we said, oh, that's great. And of course, he and I both, being framework people, were like, how are you building it? What are you using? Because we were like, he's using SAM, or he's using serverless, that kind of thing. And he said, I'm rolling my own. I write my own scripts. And we both just kind of went, here's the problem with that. When you're dealing with your own scripts and when you're writing that, most likely a lot of times you're dealing with one resource at a time. I'm dealing with the Lambda function, then I'll go deal with the API gateway. A lot of times we haven't got to where it's dealing with the application, right? It's hard to version, replicate, and share like I just talked about. It's extremely verbose. There's a lot of typing going on. And it's prone to errors, right? The more code you have, the more configuration you have, the more scripting you have is more prone to error, right? So now what you're doing is you're writing two applications. You're writing the original application that you wanted, and you're writing the application to help build the application that you wanted. And sometimes there's even applications to help build the applications that you wanted, right? So it becomes very error prone. So here's a solution with that. The mistake that I made was writing those on, and to fix it, I went to infrastructure as code. Now, if you're not familiar with infrastructure as code, it allows you to actually declare your infrastructure, your serverless infrastructure, your code, all that in a template. And you can take that template and you can drop it somewhere else. You can say, I'm going to launch it in another region. I'm going to launch it. I'm going to pass it off. I'm going to sell it. I'm going to, whatever. But it allows you to do versionable, replicatable, shareable code. And it deals with these frameworks like a SAM or a serverless framework or a CDK or an ARC code or something like that. They deal with the application instead of just the resource. So you get into a lot of interaction between the applications. So it helps with security. It helps with best practices. I encourage you to use infrastructure as code when you're doing that. And I've talked about some of these, but some of the ones that we have at AWS, of course, is AWS Serverless Application Model, which we call AWS SAM, and it comes with the AWS SAM CLI. And this was purpose built for serverless, right? We have AWS Cloud Development Kit, which is CDK, and that is not just serverless, but it is another way of doing infrastructure as code, and it deals with serverless really sweet. And the AWS SAM CLI works with the CDK as well. And we have Chalice written for Python. And these were, again, designed for serverless. And we have some third parts, great stuff out there. We have, obviously, I'm sure you've heard of Serverless Framework or Go Serverless. And we're going to hear from Jeremy a little later, who works with this team. Phenomenal. There was a time I used serverless as well. So, a great framework that's doing amazing work. Architect, Brian LaRue and his team, doing some great stuff out there with ARC code. So check one of these out. Another quote we had in the Twitter says, David Soul said, finding where I'm supposed to make and deploy the Lambda. And the console with SAM, with the CLI, with layers, CloudFormation, serverless framework, what do I do? Well, the answer to that, David, honestly, is use a framework. And this is the takeaway, right? My mistake was to roll my own. I encourage you to use a framework. All right. Mistake number 2, and I want to take a second and talk about the mistakes itself. I'm using the word mistake because, we could market it and it has the buzzword and things like that. But the reality is it's almost like a challenge or it's a change in thought, right? So it's not necessarily that it's wrong, but it's not changing with the technology, and it's not being aware of the technology. And you may disagree with me on some of these. That's okay. I'm right. That's how it works. And I'm just kidding. There's different ways of approaching this, but again, these are things that I learned that helped me move much faster in serverless. All right, mistake number 2. The shoehorned lift and shift. What do I mean by that? Well, so before I came to Amazon, again, I was a solutions architect at Rackspace. And one of the challenges that we had was we would help customers migrate from on-premise or whatever to the cloud. We would get them into the cloud. And one of the challenges we had was to move them on just the basic lift and shift, right? So we would move them over, and we always rolled out this plan and say, here's the steps we think will work. And the first is just get in the cloud. Right. Let's get your stuff over. Let's spin up some EC2 instances, some containers, whatever. Let's get it in the cloud. Some low-hanging fruit. Stop using an instance for database. Let's use RDS. Let's use API gateway. Different things like that. Let's get you or ELBs, that kind of thing. Let's get you out of your data center onto the cloud. But don't stop there. And that's one of the issues we had. Sometimes people go, okay, we're in the cloud. It's going to be cheaper. Nothing's going to go wrong. Wait a minute. I seem to be paying the same amount, or I'm not taking, this isn't working how I expected. And the thing there is we weren't taking full advantage of the cloud services, and especially the cloud native services. So consider a legacy app, right? It may not be exactly like this, but to get our idea, we have this where in our legacy app, in our system, we have our auth, our caching logic, our throttling logic, routing, storage, backend, error handling, retry logic, and our front end, right? And all that's kind of in there. Now, a couple of those may live somewhere else, depending on how you build it. You might have some tiers and things like that. But in general, we've kind of said, all right, we're going to handle all this at code, right? A lot of this is handled at the code level, right? And so when we take a lift and shift, we go, okay, I'm going to take that and I want to get that to serverless. I want to get to a serverless framework, and I want to save that money and have that scalability. And so we do this, and it often looks like this. We have our API gateway. We have our storage, because you can't store things right in the Lambda function because they're ephemeral. But everything else sometimes just gets shoved into that Lambda function again, right? You have your auth, your caching logic, throttling logic, routing, backend, so on and so forth. And while this will work, and yes, you get the scalability of the Lambda function, are you truly taking advantage of the services? And are you really getting everything you need to get out of serverless? So here's the problem with that, right? So the first problem is, in this, you have a multi-responsibility pattern, meaning that Lambda function is handling everything, right? And it's scaling across multiple Lambda functions, and hopefully, you've coded so that it can do that. But you're not, we often talk about using the simple, and not even serverless, just in coding, is the single responsibility pattern. Do one thing and do that one thing really well. And serverless really encourages that in having the way the separate compute works, is saying, look, I'm going to do one thing, I'm going to do that one thing really well. But when we push it all in, when we shoehorn it into that single Lambda function, then that's multi-responsibility. The second thing is, it's a lot of unnecessary lines of code. We're taping things together. There's the glue, there's there's pushing all that together. And the third thing is reduced durability. Now you may say, well, Eric, hang on a minute. How does that present reduced durability? Well, here's the thing. If you've ever heard me talk about this, or if I've ever worked for you as a developer, you're going to quickly know that the most brittle part of an application, an Eric Johnson application, is Eric Johnson's code. Okay, that's just the reality of life. And and I'm not alone here. Maybe some of you are like, well, that may go for you, Eric, but not for me. Well, hang on a minute. Here's the truth of that. The code of our applications is the most iterated on part, right? That's the part that changed the most. And every time we make changes, we introduce the opportunity for problems, for reducing durability, right? Even if you're a phenomenal developer, sometimes we hit, a Q instead of a W. I had to look at the keyboard. What letters are close together? And so we get this idea of, we fat finger, right? I have one finger on each hand, and I am the eternal fat finger. I mean, and I go to hit a Q and I hit an M. They're not even close together. We introduce mistakes when we're constantly changing, right? So it reduces durability. Now, the solution for this is a true migration, right? Is to actually take and make use of the services that are there and the purpose they're there for, right? And so this when we offload process to managed services, we introduce a single responsibility, or we try to, where we're breaking those Lambda functions out, and each one has its own, and it increases durability, right? Because we're not changing code so much. We're also decoupling our services so that one Lambda isn't doing everything. And if that one Lambda goes down, my application goes down, right? If that Lambda function has bad code, whereas if I split it out into individual single responsibilities, if that one responsibility, something's wrong, the others, if set up properly using pub sub and queuing, technologies that we use in our code anyway, others should degrade gracefully and say, you know what, that's down, but we'll go ahead and put it in a queue and we'll get that feature done a little later. So let's go back to our shoehorned Lambda. So here it is. If we were to take this, and this is just one idea. There, like any other technology we work on, there's lots of ways to do things, but we could then take and say, okay, I'm going to pop this out. So here's what my new application looks like. First of all, I've taken my front end and I've put it out in an S3 bucket, but at AWS, I'm going to use Amazon, but some type of static site hosting, and a lot of the clouds offer it. And again, AWS, that's Amplify, where it's going to handle my CDN, my content delivery network. It's going to handle some routing for me, things like that for the front end, but it's based on the durability of 11 nines through Amazon or through S3. The next thing I'm going to do is I'm going to move my authoring and my caching, my authorization, my caching, my throttling, and my routing out to API gateway. That's what it was made for, right? So our API gateways do a lot more than just you go there, you go there. It's like, should you be allowed to go there? And do I have a cached response? And are there too many coming in? Do I need to throttle that down? So I move that logic out to there. I move my error handling into my bus and my queues and my pub subs and my different technologies that are designed to say, I tried it once, it didn't work, let me try it again, and then back off, right? So a lot of them have different technologies to be able to do that kind of work, right? So again, when we're looking at this, instead of doing the shoehorn into just, all right, I'm going to do it all, just cram it into a Lambda function, everything's handled at compute, use the services. I like how Joe Emerson puts this. He says, I think the biggest adjustment is thinking in systems, right? To do serverless right, nothing is ad hoc. Everything is a set of systems written declaratively that is brought to life by a service provider, right? It's so I'm going to say it much more eloquently, much less eloquently. What I say is migrate beyond the lift and shift, right? Don't stop there. Get it in there. Sure. Hey, I need to get into serverless. Boom, I'm serverless. Woo, yay. But then you start evaluating what can we move off, right? So the next mistake is a continuation of this, right? No, we're going to go a little deeper on this, but my mistake also is, and y'all can shake your head and roll your eyes at me, but I know a bunch of you are guilty of this too. It's code over configuration. As developers, we're coders, right? We're code hackers and all those stuff. You see, like code monkeys, whatever we want to say. And we want to fix and do everything in code, right? Because that's what we're paid to do. But sometimes it's just a simple matter of configuration. So let me ask you this. When you're building, when you're setting it up, how much logic are you squeezing into your code? Think of the last Lambda function you built, or the last application you're building, or something. And is it full of if-thens and switches and evaluations and those kinds of things? Or if this, then do this, then do this, do this. Then, like me, you might be doing it wrong. I remember just before I came to AWS, I was building an application for a company, and they needed. I was actually doing an integration with Stripe, and when I built the integration, we had subscriptions. There was all kinds of if this, then this, then this, then this, and this. And I built it, and I had this Lambda function, and man, I was guilty of this so bad. I had 9 billion lines of code saying if the subscription worked, then do this. If this worked, then do that. And if I could go back and do that now, I would do it entirely differently. And I'll show you what that looks like in just a second. The other side of this is how little are you invoking a Lambda function for? How little logic are you invoking a Lambda function for? Right? So here's the problem with that, both of those. A lot of times we come up with it's either unnecessary Lambda invocations or unnecessary lines of code or reduced durability. Now you're like, well, hang on, Eric, you used these points in the last mistake. Yeah, I did, but it still introduces the same kind of problem, right? If I'm solving everything through code, then I'm again, and I won't go through the whole thing, but that iteration process, it's reducing my durability. It's banking on the Eric Johnson fat finger factor. I had to practice that one. Right. So the answer to this is only use Lambda functions when necessary. It gives us an inherent reduction in code and increased durability. You're like, man, well, that's the obvious answers. But let's look at what that looks like. Okay, so let's go back to my, the application I was building for Stripe, or here I'll bring up this example, and this is you're building a trip, right? So and everybody's, we've had a lot of people do this. I know Hader Lester's built the airplane reservation system. This is using orchestration. And for AWS, that's AWS step functions, right? The state machine. This allows us to say, hey, instead of me building a ton of logic into a Lambda function, including the error handling and the retry, I'm instead going to break that out and pop it down into little bite-sized chunks and handle it through orchestration through a state machine or a step function. And so the step function built into it with configuration is the ability to say, if this worked, then do this. If it didn't, then do this. If it worked, or if it didn't work, then you can retry it a little bit. And so you get to make choices codeless, right? These just through configuration, I don't have to code those choices or the results of those choices into my application. I can configure the retry, I can configure the error handling. And then what happens is each Lambda function contains minimal logic that is applied to the application, right? It's at Amazon we say this a lot, or AWS, it's undifferentiated heavy lifting. You don't want the stuff that doesn't matter in your code. You want the stuff that matters, and that's what becomes very apparent in your Lambda code. Now, the other side of that is this. Is the Lambda function even needed? And Jane Eyre said, and this is quite a while back, but I just love the quote. It says, Serverless Pro tip number 72. If you are just using AWS Lambda to copy data around without doing anything to it, there's probably a better way. Or AWS should build or is building one, right? See Firehose, cross-region sync on S3, etc. But the bottom line is use Lambda functions to transform, not transport. So don't let Lambda functions be the sledgehammer or the hammer to just transport. Get it out of there. Now you go, well, Eric, how do I do that? Well, we have several services to do. This is just a couple examples. Number one, API Gateway, HTTP API endpoints will directly integrate with Amazon SQS, step functions, Amazon Event Bridge, Kinesis data streams. What that means is I can configure. Now, we can get into the debate, YAML is, code, stuff like that. But in this example, it's configuration. I'm laying the rules, it's configuration, okay? I can configure HTTP API to talk to these services, right? Or with AWS step functions. AWS step functions integrates with a ton of services directly and are adding more all the time. So if I want to do DynamoDB or SageMaker, or I have some container workloads I want to run in on Fargate or Elastic Kubernetes. The bottom line is evaluate your code. Are you just transporting that? And is it necessary? Or are you applying business logic? When we're applying business logic, then I'm not anti-Lambdas. I've had people ask me, what, like AWS Lambda? I love AWS Lambda. I told you, why would I do it any other way? But I don't like using tools that aren't needed. I like the simplicity and streamlining of just directly integrating with the service and letting it handle the retries and the errors and things like that. In fact, last year at Serverless Nashville, Serverless Days Nashville, I did a whole talk on this. It's called Thinking Asynchronously, but I talked about direct integration. Now, and you're welcome to hear, this is a QR code to that, or you can, the short link. The idea behind this particular one was so first of all, we directly integrate and we only use services when we need to. So it's pulling those Lambda functions out. And I talk about doing that. The second reason I talk about this, and you may have heard me say this word, is I really believe in what I call a storage first approach. Now, I didn't put it in as one of the mistakes, but it's something that I've learned going into serverless or coding itself. And what that means is when I build an application, the standard practice for a web API would be something like API gateway to a Lambda function to DynamoDB or something like that. And what happens is that the request comes in, I apply all my business logic at the Lambda function, and then I save the data. The problem with that, and that's usually a synchronous call. The problem with that is, what happens if my code fails? Well, I lose the data, right? So what I encourage you to do is to do a storage first, where instead I go REST API, and in this example that you'll see here, I use REST API, but again, we can use HTTP API, REST API to DynamoDB, and then I trigger a Lambda function off the streams. The difference there is that data is persistent in DynamoDB. Regardless of how bad Eric Johnson's code is, and what kind of damage it does to the data, that data is still available. So, for example, I don't have to go back to my customer and say, hey, can you give me your credit card again? I'll get it right this time. I may have sent it out to a bunch of people accidentally, but we got it right. So we don't want that, right? So instead, I could say, boom, that's stored. Now, credit card may not be the great, best example because it's PCI, but let's say something else. But that data is stored, and I can react and I can grab it again based on my error handling, things like that. One of the responses I got, and I love this, from Laura, she says, "What? I can't persist anything in serverless? That's mad. It will never work." Oh, all right. Stick it in DynamoDB. Serverless light bulb moment. Exactly. That's what I'm talking about. And Jeremy Daly and I talked about this. His choices, he likes SQS, but you could do Event Bridge. There's all kinds of persistent storage first examples to do this. But again, it goes back to using the right tool for the job. One other example I have of this, and you're seeing it all through this, is this S12D.com. S12D.com is actually built on top of what I call a lambda-less URL shortener. And I did a blog on this last year, and we use this for all our shortening. And this is built on REST API talking directly to DynamoDB. And there's just a little pinch of business logic that happens in VTL. Yes, that's right. Velocity templating language that we apply to that. But again, I didn't need a Lambda to just say, convert that, just transform the request a little bit. It's not really applying business logic. It just needed to look differently when it got to DynamoDB. So, and it's very fast. Lambda doesn't add a lot of latency, but anytime you do a hop, there's latency, right? So this is directly API gateway to DynamoDB and back out. It's all cached out on CloudFront. It's wicked fast. So take a look at that. This will give you an idea of the code, how it works. And so that's another example of that. Phil Bassford said this: I would say that you need to enter a mind space and skill level where AWS serverless services are the actual programming language and constructs. Don't try to program an app in a function. A function is a function. A queue is a queue. Use AWS as your language. I love this statement. I said the exact same thing, only when I said it, it looked like this: code only as a last resort, right? So this is my takeaway for this is, man, don't go code first, go configuration first. Use the services and code only as a last resort. All right. Mistake number 4. Okay. That's also how I did Marco Polo. All right. Mistake number 4, bring the cloud to the developer for testing. Now what does that mean? Well, I'm going to explain. When we first started building, and all of us are guilty of this, we built emulators and we tried to bring serverless all to our desktop and get a full-on working, basically AWS cloud serverless, on our desktops. And there are reasons we did that. For me, I always made the excuse, well, what if I don't have internet? What if I'm on a flight for 363 days? All right, so that's one of the things we make. The second one, and this one's probably a little more legit because I would push back and say, yes, I fly a lot, and I plan before I'm getting on because I don't rely on airport or airline internet. I plan before I'm getting on. I plan accordingly. I prepare myself to not have internet. I load 3 or 4 shows onto my iPad and don't work. So there you go. Little tip there. The second excuse that we see a lot, and it's a valid one, is Eric, uploading takes forever, right? Even if I'm using a framework, I'm using a SAM, I'm using a serverless framework, I'm using CDK, I have to redeploy my app if I want to do it in the cloud, right? I want to say, all right, I've made these changes, upload. I've made these changes, upload. And we sit there and we count and we wait and we go get our drink of coffee. And I mean, even the snail beat us even just explaining this. So uploading takes forever. But let's talk about the alternatives for a moment. Okay, service simulation. All right, and I'm not the only one. You may recognize this. Darko and I had a discussion on Twitter about local Lambda on his Pentium 286, whatever he was building. But let me ask you this question: how much time have you spent configuring local service emulators? I submit, for me, that there's probably more time than I've been on an airplane and needed to work, right? We wrestle with these. And here's a wise man once said to me while I was talking to myself, I would rather wrestle with cores than Docker network. And if you're not familiar with cores, believe me, that's bad stuff. I just did a lot of work around cores, and it's just not bad. It's just hard. It's complex. It's trying to figure it all out. But I would rather do that than deal with Docker network and try to get my stuff to talk together. Here's the problem with that. So first of all, emulators are never the real thing, right? We can say, oh, they're close. They're close. They're never the real thing. And I'm not picking on anything. AWS same thing. It's not the real thing. And we know that. We're not trying to build a full API gateway and a full Lambda service inside of AWS SAM. It's not the real thing. We spend a lot of time getting emulators close to the real thing, right? Well, if I just make this one more thing and I try to deal with authentication and those kinds of things. And even more time is spent or lost getting the emulators to work together. I'm going to use my S3 emulator and I need to work with my Lambda emulator and I need Docker network to talk to itself. And I know most of y'all are smarter than me. You're like, I have no problem with Docker network. And that's great. But it's not easy, and sometimes it's complex to get it. The next thing is emulators are often outdated. It's a chase the cloud thing, right? When we put out a service, the emulator has to respond and try to emulate. But we don't know exactly all the underlying things going on. And finally, security is often bypassed. And I would say security is almost always bypassed, right? So when I'm running local emulators, and by design, we don't check for credentials, things like that on local SAM, because that's not the purpose of it. The purpose of it is just to locally invoke that Lambda function to see if the code works. We want you to test the security and things like that out in the cloud. So here's a solution to that. Bring the developer to the cloud. Instead of the cloud to the developer, bring the developer to the cloud. Cloud is always the real thing. It's always, the cloud is the cloud, right? It's always the latest and greatest. The latest features are going to be there. You're never going to see an emulator offer a service that a cloud doesn't because you work in your local emulator, but not in the cloud, right? No configuration past regular infrastructure. I'm not having to configure Docker network. I don't have to worry about, different things like that. And security is enforced. And you quickly know, oh, if everybody can get that, my security is too wide open. Oh, nobody can get to that, my security is too tight. But that's the way it works, and that security is enforced, right? And we believe that to bring the developer to the cloud is the best way to go. We've been talking with the same team and with our serverless, and we think that as much as you can test in the cloud is the way to go within reason, right? So let's take a look at that. So back to our service simulators, we got, there's different things, queues, compute, storage, things like that. And how we want to approach this is we want to have minimal service emulation, right? I'm going to just get exactly what it needs to be able to run locally, to iterate against my code, right? I don't need to iterate against configuration. I'm going to push that out there, but iterate against my code. And that's what SAM and serverless framework and a lot of these do today, right? And CDK through SAM is it gives us ability to say, hey, I'm going to invoke my Lambda directly or through an API gateway emulator. And that API gateway emulator is not API gateway. It's just an emulator that can give the proper context and request, and then the response back out. And how we think we should approach this is local iteration of Lambda function code. This is where that happens. But don't emulate DynamoDB or step function, things like that locally if you're going to interact with it. A better way is to communicate with actual services. When I build my local SAM, my Lambda, when I'm running SAM local, my Lambda function can talk to DynamoDB in the cloud. I don't have to emulate that locally. I can talk to it in the cloud, right? So, and then run integration tests in the cloud. When you get to that point, when you're past the local function code and you're looking at integration in end-to-end, things like that, do that in the cloud. I love this. Levi McCormick said, local development. I assume a locally role, this is how he approaches it. I assume a role locally and use a test event to run my code against live AWS APIs. Exactly. Instead of trying to mock out every service. That's right. Then get continuous deployment to push my changes as soon as they're checked in and do full tests in the cloud. Good answer, Levi. That's the way to go. And how I say it is bring the developer to the cloud. As much as you can push that out, you bring the developer to the cloud. And I would love to say, okay, that's the end. We're good. But uploading for testing is still too slow. And we know it, right? We've been talking about that as well. We know that, Eric, that's a great idea. But I don't want to wait 3 to 5 minutes or even 1 minute for deployment every time I want to test a change. That's not realistic. So what's fun is we're introducing, and we're calling it SAM Accelerate, but or development in the cloud, introducing AWS SAM Accelerate, right? And this is going to be something built into SAM. If you didn't see it on Friday, I announced that the AWS SAM CLI is going to public roadmap, and you can see all this information in here, and I'll give you a link to that in a little bit. But here's something we're working on to help you get as much into the cloud as you can, bringing the developer to the cloud. So the purpose of SAM Accelerate, AWS SAM Accelerate aims to increase infrastructure accuracy, and I'll explain that here, for testing with incremental builds, SAM sync, and aggregated feedback for developers. So let's go back to this. Now, what do I mean by infrastructure accuracy? Well, I already kind of talked through it, right? Emulators are not accurate. They're not going to be able to test everything just like it's going to be in the cloud. It's not a production environment. We want you to be able to use production environment. And the beauty of serverless is you can have in your development a production equal environment because you're using infrastructure as code to build out your stuff. So what it looks like in development is what it's going to look like in production. And if it's not that way, you need to reevaluate it because you want it to look that way. So our goal is to bring you infrastructure accuracy to test. And the first thing we're doing to do that is incremental builds. So let me kind of explain this. Currently, when you're building an application, everything is updated in a build or in build when you do that. So you say SAM build and it's going to update your code. Now this is Python, so it's not compiling, but it's kind of minimizing, getting it all ready. And it also updates the dependencies every time. So we go out, we reload all the dependencies, and we put together code, and that's time that isn't really used. Now we cache that so that if that function didn't change, it doesn't get done again, but we want to break that down even smaller. And so we're breaking out that cache and we're saying, now let's say I only change a line of code, but I don't touch my dependencies. Now when I do SAM build, it's going to leave the dependencies alone and it's going to just update the code itself. So these are incremental builds, and we're looking to do even more with this, where we really break the dependencies out for you, and we break out the code so that we can quickly update that. SAM build, test, SAM build, test, SAM build, test. Very easy to do. The next thing we're adding is what we're calling AWS Sync, right? And this is actually part of this accelerate movement here that we're doing. And so to do this, to understand AWS SAM Sync, I want to first explain what we consider code and what is configuration, right? Because it's going to be different on how SAM syncs everything up. So as we're going through this to help you understand, we consider code to be Lambda function code, Lambda layer code, step functions Amazon states language, and Amazon API Gateway Open API. Okay, we consider those to be code. Everything else is configuration. So let me walk you through an example of what that means. So first of all, we do SAM sync. Okay, now what this is actually going to be a command where you just say AWS SAM sync. The first time you run it, if your application is not deployed, we'll go ahead and deploy it, right? If it is deployed, then we'll just update it based on the explanation that I'm going to talk through here. So currently, any changes right now are an update, and the whole stack is updated. Now, CloudFormation is smart enough to say only update the things that require, so only change the deltas, but we run the whole thing, including the dependencies, including the code, everything like that. With SAM sync, now we're going to change it so that if you just change, for instance, the Lambda function code, then we're going to call the update code feature. Instead of doing a deployment, we're just going to do a quick update code. Boom. So I say SAM sync, and it updates the code, and it happens very quick, and then you can test. The same with ASL, Amazon States Language. If you make a change to the states language, we'll just quickly update that for your step functions. We don't need to do a full redeployment. We'll just quickly update that. But what about an event bridge configuration? We're changing the configuration of event bridge. Well, that'll be a stack update because that's what it is. And CloudFormation will just update the event bridge. However, we come to Open API and we update the Open API, then it'll just update that script and change the API gateway. Now, this one is a little bit, I want to explain this. So if you've ever used Open API inside of Amazon or AWS SAM, there's a couple ways to do it. You can do it as a definition body inside there, or you can do it as a definition URI. In this way, I'm actually calling an external file. I just call it api.yaml, and that's my Open API. And that's how I have to set this up for this to work. So if I change the file api.yaml, then it will actually just update that code, and off you go with Open API. All right, but so again, we update the API and change to that. It just updates the Open API template. So change the Lambda function configuration, then it has to do a stack update because that's the configuration. So that's something like how much memory, what's the timeout? These are things that don't have to do with the code. And finally, a change to a Lambda layer, that's code, right? So we just push the layer itself and off you go. So those are ways that we're looking to make that much faster. And how that's going to work is you have SAM sync and SAM sync watch. So you can actually just say AWS or SAM sync -- watch. And then every time you make a change, we're going to do a quick deploy of either just the code or a full deployment update. All right, so the last thing we're doing is we're creating an aggregated feedback to developers. So what this is going to do is anything in Amazon CloudWatch or AWS X-Ray is now going to get pulled in with SAM logs. So let's say with a Lambda function, I have logs, I have API gateway that's being affected, I have X-ray traces. I want to be able to get all that, but I want to get it in one place where I'm not looking all over for it. And that's what we're going to be able to do with the aggregated feedback for developers. I'm going to show you an example of that. So I've got this application. And so here's what we're going to do. I've got this application. It's just simple Python, and it's a hello world. How are you today? And so what I'm going to do is I'm going to pop over to my code, and I'm going to go ahead and do the first sync. And I have not sped this up on the syncing. I did just a little bit because it's a full deployment, but that's done, right? So the next thing I'm going to do is I'm going to go ahead and I'm going to start my logs, right? SAM Accelerate, and SAM Accelerate is my beta version of this, and you'll get that if you install it as well. And you can see here, I've got all kinds of information. I have traces coming. I have the logs coming out from the invocation. And I'm going to go ahead and curl the endpoint of my application. And there I got hello world, how are you today? And you'll see, because I added the tail command to my logs, I automatically got more logs. I got more information, including the traces coming from X-ray, right? Okay, so and you can scroll up here a little bit. And you'll see that I also get the API gateway information as well. So here I've got API gateway information, the AWS SAM logs information, and the traces. And I can turn off one of those if I need to. So let's go ahead and change our code. Instead of how are you today, let's do something like hope you are well, and not a question, but an exclamation point. Now I save it, and you'll notice that instantly, and I did not speed this part of the video up, instantly it goes into deployment. It checks to see what needs to be changed. You see some of the manifest did not change, so we didn't do it, and it was done. I run a curl, and you can see the changes are in place, and there go my logs. So very quickly, you can see a development cycle where you can make quick changes. Let's make one more. I'm going to add a print statement here, and I'm going to say I have invoked. So when I do that, I'm going to go ahead and save it. I'll pop over here, and it's already doing the deployment, and it'll finish in just a moment here. And I do my deployments in parallel, so any of them would go out. It's done. So I'm going to go ahead and invoke that one more time. And then we'll see that my logs come through. And with those logs, if I go down here, there's all my traces, everything I need. I'm going to scroll back up to the actual Lambda function logs. And you'll see here, let me get to there real quick. There you can see in the logs I have invoked. So again, the idea here is I'm going to bring all that into a single place where you can see that and get quick feedback from your Lambda functions. So that quick developer feedback is something that'll help you out a lot. So I talked about it. We have an open roadmap. All this stuff is listed on the open roadmap. We are looking for your feedback, for your help. I encourage you to go there, s12d.com, sam-cli-roadmap to check that out. I'll tell you, if you want to know more about serverless with AWS, I encourage you to go to serverlesslane.com. My team builds this, aggregates it, and there's a lot going on here. I appreciate you putting up with my technical difficulty in the beginning. I appreciate you having me. I love the Serverless Days Nashville team. They do a phenomenal job. And there's a lot more really good stuff coming up. For example, Yan Kui is going to talk about building, and I know I said your name wrong, Yan, I'm sorry. Or maybe I said it right, we'll see. How we built a social network in 4 weeks with GraphQL and serverless. Jeremy Daly, optimizing serverless development workflows. He's going to get more into development. His team's doing some great things. Jamie Duncan's going to be talking about what happens to ops when DevOps goes serverless. This is a great question. This is something that a lot of people are asking about. And then we have 2 panels, serverless adoption at scale and empowerment and enablement. And with that, I'm going to check out and tell you, I'll be around to answer questions. I'll be in the rooms. I want to say thank you again. Thanks for putting up with my shenanigans at the beginning with my technical difficulties. You can find me at EDJ Geek on Twitter. I don't know all the answers, but a lot of times I know the people with the answers. So hit me up on serverless. Now, the fair warning, I talk about Dr. Pepper, I talk about pizza, I talk a whole lot about my family, but I talk a whole lot about serverless too. Thanks if you stayed to the end, thanks for listening. I really appreciate that. I had a great time doing this. Feel free to ask me any questions you may have. And with that, I'm going to sign out. Thank you so much, and I'll be in the room. Serverless for everyone. Stay cool, stay healthy. Have a good one.